Got you. Hey, everybody. Today you are probably going to need a highlighter and you need some kind of pencil. And let's turn our volume up so that we can hear what's going on. I'll write that down. Let's turn our volume up so we can hear what's going on. All right. As usual, we're going to do the left side together, and you need to do the right side and show the same kind of work. Okay. Most missed problem on the test. And again, I kind of knew this would be because when we get a decay factor, we want to say that the percent of decay is this number here. It is not this number. Okay, so I want you to draw a line to that, and I want you to write not the percent, because 91 is not the percent. Okay, so what you need to do is you need to do 1 minus what is in that parenthesis. 1 minus what is in that parenthesis. And what we get when we do that is we get 0.09. So now we take that 0.09, we know that that is our rate. And if we multiply by 100, it gives us our percent. So it is 9% decay, and we know that it's decaying because that number is less than 1, okay? So I'm going to highlight this because this is what you need to do when you're figuring out the percent for decay. It is not 91%. You have to do 1 minus 0.91, and that will get your percent. All right. Okay, next, one of the most missed in behavior. So what I want you all to do is, let's put some arrows on these because the arrows are understood if the picture goes to the end of the graph. Yeah, I think we need to think about on where is the curve pointing. So if we look on this side, is the curve pointing up or down? Well, it's pointing down. So since it's pointing down, y is getting smaller. Okay? Pointing down, y is getting smaller. If it is pointing up, y is getting bigger. Okay. So pointing down, like this one, the y is getting smaller. Pointing up, the y is getting bigger. Okay. So on this side, we're pointing down, so the y is getting smaller. And on this side, we're pointing down, so the y is getting smaller. So on both sides of this graph, the y is getting smaller. On both sides, the y is pointing down, it's getting smaller. So how do we say that? Well, the left side of the graph is where x gets smaller, and the right side of the graph is always where x gets bigger. Now, y'all, that's always. Always on the right side, x is bigger numbers, and always on the left side, x is smaller numbers. The trick is what's going on with the y. So on the right side of the graph, x is bigger, but the graph's pointing down, so y is smaller. So x is bigger is here, y is smaller. X is bigger, y is smaller. Okay. Now let's talk about this side of the graph. On this side, x is always the smaller numbers, and since it's pointing down, the y is smaller. So right here, x gets smaller. That's this side of the graph. The y gets smaller. okay? Here, X gets smaller, Y gets smaller. Here, X gets smaller, Y gets bigger. No. So this has to be the right answer. Okay. So when it's pointing downward, that is Y getting smaller. When it is pointing upward, that is Y getting bigger. So hopefully that helps a little bit. Okay. All right. One of the most missed problems on the test, and I think I know why, because we probably didn't realize that this is a Y value. So we're going to have to use Desmos. That's a Y value, so we're going to have to use Desmos. So first of all, we need to write our equation. So we have $1,500. It is increased at a rate of 6%. So my equation is Y equals 1,500, parentheses, 1 plus, because it's increased, 6% is 0.06, and then we're going to raise it to the X power. So in Desmos, we're going to put that in, and then this is not an X, it's a Y. So we're going to put both of these lines into Desmos, and we are going to find the intersection. Now write all this down. Okay. And now I'm going to try to switch this screen. Let's see how well I do here. Give me a minute. All right, so hopefully this is going to work. Okay, so this is another problem. Let me go ahead and pull up another Desmos. Okay, so what I'm going to do is I'm going to type in both equations. Y equals 1,500, 1 plus 0.06, and don't forget raised to the X power. And then we were given 6,000 as a final value, and that's a Y value. Okay, now what makes this tough is we're going to have to go find the picture. Well, notice if my Y is at 6,000, if I go over here to the tool gear and I take a look at my Y axis, I've got it at 6. So y'all, let's make this bigger than 6,000. Let's make this about 7,000. And what you'll notice is you're beginning to see the picture. Here is your line Y equals 6,000, and here is your exponential. And somewhere on the right-hand side over here is where they're going to meet. So right here is where they meet. And notice they meet at 23.791, comma, 6,000. They meet at 23.791, comma, 6,000. So what I'm going to do is I'm going to go back and write that down. Okay. So 23.791, comma, 6,000. It says round to the nearest year. So that would round up to 24 years. Okay. All right. All right, most missed question, one of them. First of all, we got us a table, and what is going to be important here is that we recognize the phrase exponential regression. And when we see that, we know that we're going to do y1 approximately equal to b raised to the x sub 1. So we're going to put this in the table in Desmos, and then we're going to put that in. And then this particular question says, determine the temperature. So we're looking for temperature after 50 minutes. So this that they're giving me is an X. So I'm going to type in X equals 50 after I get my first equation. Okay, so let's go on over to Desmos. And I am going to go to this one. And if you'll notice, I have already typed in the table, and I have already typed in my exponential of best fit. And what I wanted to do is I wanted to show you that when you have a table, folks, it's really easy to find your exponential because you can press the Zoom Fit button and there she is. Now it gave us X equals 50, and I am going to type in X equals 50. And if you'll notice, it's way over here in the bottom right corner. And when we type that in, we get 88.055. 88.055. Okay. So 88 is the correct answer. Right, find the intersection. Okay. All right. Last one. Question number 5, one of the most missed. This is where there's two things going on. We're saying whether the function is increasing or decreasing, and we're saying whether it is positive or negative. So this is what I want to do. I want us to take some notes here, okay? So when we are above the x-axis, that's up here, our function is positive, okay? So I'm trying to think, how can we write this down? Okay, let's see. So let's draw a line right here. This is your x-axis, okay? So when we are above, our function is positive. Okay? So everything in orange here is positive. Okay? When we are below the x-axis, our function is negative. Okay? In other words, what we're saying is the y values down here are negative. And up here, the y values are positive. So that's when you say a function is positive, you're saying the y values are positive. When you're saying a function is negative, you're saying the y values are negative. So I'm going to grab a different color here. Under the x-axis is where my function is negative. Okay, now, increasing and decreasing is a different story. When I am driving in a car, we are always driving from the left-hand side. We always drive from the left, like we read, okay? If I'm driving from the left-hand side, if I begin to go uphill, okay, that's increasing. If I go downhill, that's decreasing, okay? So don't confuse the two. Don't confuse increasing with positive, okay? Increasing is when we drive up the hill. Positive is when we are above the x-axis, okay? So let's take a look at the interval they're giving us. They're giving us the interval from -2 to 0. So here's -2 to 0. So here is the interval that they want us to take a peek at. Right there. So now, when I take a peek at this, it is above the x-axis, so the function is positive. But when I'm driving in a car from the left, I go uphill, so this is increasing. But once I hit this point, I begin to go downhill, so this is decreasing. So above the x-axis means the function is positive, but I am driving downhill, so it is decreasing. So function is positive. I'm driving downhill, it is decreasing. So here is the correct answer. All right, you guys have a great day.